Can you hear me? Yes? So, good afternoon, everyone. Maria Marques. I am in charge of roads and railways business in Egis, Global Transportation Director. Egis, as you may know, is a global engineering firm, also an operator that covers energy, water, building, aviation, and of course, transportation business. With a global turnover of more than 2 billion euros and more than 2,000 employees around the world, our mission is to conceive, to design solutions that promote sustainability and that ensures the development of the different regions. It is a privilege for me to be here today with you and with my two talented colleagues, Zineb and Doha, to present you the path that Egis has been building since the last 20 years in the fascinating world of railways. And I invite you to walk this path with the lenses of innovation. So just before beginning, let me share with you a video that will allow us to jump directly into the subject. As we look into the future and as we look back to the past, the importance of innovation cannot be overstated, and in particular on the railway sector. Railways have been the backbone of our transportation networks, connecting cities, regions, countries, facilitating the economic growth and the social development. Our journey began with a commitment of excellence and innovation, and over the years, Egis have been involved in so many transformative projects worldwide. In the past 2 decades, innovation has not been an option for the projects, but it has been the keystone on top of which we have built designs, teams, plannings, operations. I would like to travel with you and to take some examples around the globe. Let's begin here in France with Grand Paris and with Eole projects. Eole aims to improve the connectivity between the west and the east suburbs of Paris. And Grand Paris is willing to create a comprehensive network connecting people, airports, residential areas, economical hubs. Both projects have been very challenging in terms of seamless integration in a very dense urban context, and this constraint has been a catalyzer to innovate in terms of intermodal connectivity. It has been key to provide seamless travel options for our customers. From an innovation perspective, smart station design has been fostered thanks to these projects and by including real-time passenger information system, efficient lighting, climate control systems, improving not only the passenger experience but also the operational efficiency. From a construction perspective, and as we were saying these projects have been developed in a very dense urban context, both projects have utilized state-of-art tunneling solutions and techniques to efficiently construct underground lines, minimizing the disruption in the existing infrastructure and urban life. Let's now move to Europe, to other part of Europe, and take the Rail Baltica project as a flagship one. Rail Baltica, almost 900 kilometers connecting the Baltic states, has been pushing very far the standards to facilitate cross-border transports. This project leverages digitalization and smart technology, includes advancing signaling systems and real-time passenger information to enhance the safety and the operational efficiency. My colleague Zineb will enter later into the details on how the latest telecommunication innovations and standards will make it happen, and how telecommunication network will be one of the key stones to support all services and applications related to IoT and data analytics. We are also actively contributing to the high-speed programs in Czech Republic. From a very early stage, we are already integrating how innovative construction techniques will definitively help to optimize the planning, to optimize the building processes, and ensure timely delivery of the infrastructure components. Let's continue our travel and move to the Middle East. Oman Link project has been a game changer in terms of beam integration from the very early design stages and has set the path for the future projects. BIM has fostered collaboration between different teams in multi-site and covering different domains. My colleague Doha will just enter into the details and explain also how BIM has contributed to mitigate the risks and to avoid them, and how to facilitate the asset management tomorrow. Let's continue to Americas. High-speed rail in California. It is also an example of how the BIM helps us to assess the system approach on a global perspective, and facilitates, of course, this system management of a transportation network. Still in Americas, another completely different project, on corridor project for GO Transit network. The objective of this project is to increase the capacity, the service frequency, and the reliability for the different commuters across the region. The transition from diesel to electrical trains has been a major component of this project, aiming, of course, the reduction of the greenhouse gas emissions. We have pioneered on these electrification projects and significantly helped to reduce our reliance to diesel, lowering our carbon footprint. By incorporating renewable energies, we are a contributor to a greener and more sustainable future in transportation. All these projects that I have just introduced, all the projects that are in the slide that you are seeing, have been key to set the basis of an innovation axis that I am particularly proud of, which is the ecodesign process, aiming to ensure not only the sustainability, but also the capacity to create a richer environment from an eco perspective. Ecodesign is also a must to cope with the challenge of resiliency and adaptability. So, our journey through these past years have been marked by continuous evolution, by a strong commitment to sustainability, and to integrate the latest innovations. All these innovations have been pushed, of course, by technological evolutions that have been impacting the solutions that we can propose to our clients, enhancing them with IoT, with data analytics. But we have also, as we are going just to see later, they have also served these innovations to improve our engineering tools. And both engineering tools and applications to our customers have served to fill our commitment, our sustainability commitment. We have seen the applications before on the client side, on our customer side, on our engineering tools for our needs. Engineering 4.0 is a reality for us. And let me highlight some of the tools that we are already using in our projects, like Quantum, that thanks to the fact of using EIS tools and mixing it with traditional tools, allow us to have an overall view of the project and have all the alignment constraints in order to propose the best optimizations in the production environment. We are also working with our teams in trials with virtual reality that enhance project collaboration between teams in distant sites working for the same project. These innovations not only serve the design phase, but also the supervision and construction phase. Let me, for example, talk about Bulldozer, which is helping us to assign the priority tasks to ensure better follow-up and to facilitate the travel routine, and to having automatic dashboards that can be shared with our clients. We do have also tools of Gamma Air that are available for the indoor works, and then propose augmented reality solution to visualize the final project. As I said before, our sustainability commitment has been at the heart of our operation of our innovation axis. Egis applies the eco-design approach through these innovative solutions, tools and expertise that are in line with the 7 stakes of our Act for Eco-Design reference framework. If I was to highlight one of the major tools for us, I will choose EVA Carbon, that allow us to identify the highest emission source and to propose optimizations to lower the carbon footprint. So innovation is a transversal process that is fully integrated in our business stakes and objectives. So we have seen the past, have seen the present. Let's look at the future. What is ahead of us? If we look at the key trends, well, I could have spent 1 hour talking about the trends that are in front of us. Let us focus on 3 of them. First of all, the autonomous train, which holds immense potential for innovation in rail travel. The technologies behind it promise increased efficiency and safety, and paves the way for transformative changes in how to operate in a more safe and efficient way. Another pivotal trend that is a reality today and will continue to be tomorrow is the multimodal integration. How to seamlessly connect rail with other modes of transportation to enhance the connectivity, and the passenger experience in a more comprehensive and convenient travel experience. This integration is vital to create a truly interconnected transportation network. And of course, we will continue to be pushed by digitalization and smart systems that are already revolutionizing the way we manage and the way we operate our railway infrastructures. These advancements, this progress will enable us to optimize operations and improve the service delivery and enhance the overall experience. However, these opportunities have some challenges in front of them. First of all, the climate change. Climate resiliency is a pressing issue, and our innovation will need to serve on how we cope with this subject. We need to focus on how to build infrastructures that are resilient and that are able to recover in case of problem. Building resilient system is essential to ensure long-term sustainability of our transportation networks. We must also navigate in a framework of regulation and safety that will need to evolve as long as our technical solutions evolve and along with the new innovations that will be fostered. And last but not least, the financing, which remains a critical challenge. Seeking for funding for complex infrastructure projects will be necessary in order to secure all the resources that are needed to implement this project. And before giving the floor to my colleagues, let me share as a conclusion the importance that collaboration across the industry will have if we want to strengthen and to have more synergies and to drive a collective process. The rail ahead us present challenges, and it is also filled of opportunities for innovation and for growth. Together, we can build a more connected, innovative, and sustainable transportation system. Thank you very much, and now I leave the floor to Zineb for the telecommunication innovation presentation.
Thank you, Maria, for the introduction. As Telecom Lead working for Egis and a passionate railway enthusiast, it is a pleasure for me today to share insights and also to be part of meaningful discussion during the event. Let's start to explore how how advancements in railway system, in particular communication and signaling technologies, are transforming the way we operate and maintain our rail transport, making it smarter, safer, and more efficient. Designing and delivering a modern railway system involves more than deploying individual subsystems. It involves and requires a development and the definition of end-to-end system architecture that covers the entire railway network, and this architecture must integrate all the critical infrastructure, including the mainline and trackside equipment for power supply, signaling, communication, electrification, and catenary. Also centralized equipment for control center for traffic management and operation, passenger station for accessibility, safety, and real-time information, depot and maintenance bases for upkeep and rolling stock upkeep and servicing, and of course, all the technical building along the line to host critical signaling and communication equipment. Such a system must not only function reliably, but also address all operational maintenance and management aspects through its life cycle. Therefore, design of a complex railway system must consider and address a range of key elements to ensure long-term performance, including optimal timeline of deployment to meet project milestone, interoperable, standardized, safe and secure system architecture, resilient and performance system that support innovation and adaptability, maintenance ensurement for continuous availability and service quality, cost-effective system for operational efficiency, and also efficient interface management across systems, the stakeholders, and also by using specific tools and methodologies. And the last one is to have a minimum impact on operation during the construction and test and commissioning activities. If those elements are respected and the system is properly designed, integrated, and managed, we will be sure that we are going to deliver a cohesive and future-ready railway system infrastructure with long-term value and service excellence. The systems need also to be modern, and the urgency of technological evolution has been triggered by a combination of multiple factors, including growing mobility demands, sustainability goals, and also the imperative for enhanced safety and the constant need for operational efficiency. Modernizing railway infrastructure is not only critical today to improve the performance and prevent railway accidents, it's also essential to support economic growth and also enhance regional and global connectivity. At the heart of this evolution, we will find telecommunication and signaling systems. Telecom systems, for example, play the role of a backbone, digital backbone that supports virtually all railway operation. The telecom systems enable critical communication, seamless data exchange, and also real-time monitoring across the network. To successfully drive this technological evolution, it is needed to have strategic approach for communication infrastructure. It is needed the telecommunication must be seen not only as supporting function, but as digital enabler for railway transformation. Indeed, investing in robust, reliable, and secure communication system will ensure the railway sector to adapt to the evolving challenges, meet the service expectation, and align with global digital transformation initiative. Radio and transmission are also at the central of this evolution. One of the most transformation developments is the shift from the existing GSMR to the new system FRMCAS that we will explain after. And of course, without forgetting the shift from legacy transmission system SDH to new transmission system based on IP technologies. Egis, for decades, has been actively involved in projects covering all aspects of railway systems. In the field of telecommunication, for instance, we have designed and supervised a lot of telecommunication solutions across numerous railway locations. For example, for Depot, Egis as main design consultant, we were involved in the design studies of an implementation of multi-service network that supports all critical and non-critical applications, taking in consideration all the technical constraints of each subsystem to be deployed on the site as recommendation, security, quality of service. And also we designed a redundant data center that will host all the software and hardware of application. And we designed also a 5G private network to meet the 4.0 requirements, industry requirements. Passenger station, I think every day we are at Egis involved in passenger station design. Passenger stations are critical and strategic location because from one side we need to respect the client requirements, but also we need to meet the final user expectation, and we need to be, in our design, eco-friendly. I choose this station. It's one of the recent stations that was inaugurated last year, and Egis played the role of system integrator, and also we design all communication system inside the station. The station is number 21 of line 14 and will be connected to line 15 of one of the biggest projects in Europe, Paris Express. Control center is the railway location where critical telecom and signaling infrastructure take place. It plays also the role of operational hubs where it is needed to manage all the critical communication and also to coordinate among all the railway network. And we was entrusted with the design of a global integrated SCADA system that will supervise all asset telecom for for the Lyon Metro. And the goal of this project is to enhance the performance of the system and also to enable real-time monitoring of telecom asset, and also to gain in terms of maintenance activities. For mainline projects, we are also involved in high-speed line projects and conventional line projects. And one of the recent projects is the extension of high-speed line in Morocco from Kinitra to Marrakech. Given the scale of the projects and given the high requirements of availability and reliability, we have designed a double layer transmission network, one layer based on DWDM for applications that need huge optical capacity, and other one based on IPMPLS for resilient and intelligent data routing. This project represents not only a sample study, but also a first migration strategy from a legacy system in Morocco based on SDH to another and new modern transmission system technologies. Let's move to speak about the innovative system in the railway sector. One of them is the future radio mobile communication system. As we all know, GSMR has been the standard communication system for railway worldwide for decades. It supports essential railway operation, includes signaling and also critical communication and train operation. Built on 2G, GSMR has reliably served the railway sector, but now faces limitation due to the increasing capacity demands, aging infrastructure, and also the evolving digital requirements. FRMCS must seen not only as a new system that will replace the existing GSMR network, but it must seen as strategic enabler for digitalization of the railway network. FRMCS, by leveraging the cutting-edge 5G technology, will empower railway network to move beyond legacy limitation and also unlock new possibilities in passenger experience, safety, and also operational efficiency. By providing secure, high reliable, and robust system, FRMCS will enable railway sector to adopt innovative technologies that improve performance, reduce cost, and meet growing mobility and sustainability demands. Of course, as you can see, FRMCS will offer many benefits, but also present several challenges. Let's list, for example, the complexity of network upgrade. Migration from GSMR to FRMCS will require a replacement or upgrade of an extensive equipment, trackside equipment, onboard communication units, and also control center equipment without interrupting the operation of the railway lines. We have also the interoperability and compatibility. Both systems will need to operate in parallel for a long time of migration, and ensuring interoperability and seamless handovers between both systems will be essential to have a continuous, safe communication during the migration. We have also the problem or the issue of harmonized dedicated spectrum. In Europe, we had the privilege to define and anticipate earlier the definition of the band to be the frequency band to be used for FRMCS, which are the band 900 and the band 1900. The intention under the use of those bands for FRMCS is to harmonize the deployment across Europe and have interoperability across borders. But in other countries, unfortunately, those bands are not available, and the railway sector will need to propose the use of other 5G bands in order to use it for FRMCS, and this will require regulatory approvals and a very high international coordination, and this will need to be anticipated before any migration strategy. We will need also to start introducing the IP technologies for our railway network. It's clear that transitioning from legacy systems based on SDH to IP technologies may be complex, especially for railways operators that build their entire network around SDH. It will require a huge investment, meticulous planning, and also support from vendors. Railways operators rely on SDH for critical application like signaling and GSMR, and this is why we need to adopt gradual migration strategies, starting from migration, for example, by specific function, specific segments, or migration by geographical location. And with the use of IP technologies, we have the advantage that we still have the capacity to send legacy system data over IP-MPLS or other IP technologies, for example. We have also the issue of competencies and training management. By the introduction of FRMCS, we are sure that we will need to have specific training management for all the railway staff, technician, engineer, and regulator and drivers. But we should take in consideration that from one hand, we have the experienced expert that possess deep knowledge about legacy systems and understand very well the intricacies of railway and the problem. From the other hand, we have the fresh experts that bring 5G, digitalization, and virtualization and all modern technology solutions. The strategy is to facilitate the coexistence between those two categories of experts and to facilitate the seamless transfer of knowledge and skills between those two categories, bridging the gap between the old and the new. This collaborative approach will allow us to have all the railway ecosystem. We will have a cohesive workforce, hybrid and capable to support our clients in their process of migration from legacy systems to modern systems, including FRMCS. Cybersecurity. As we all know, FRMCS is based on 5G. 5G is a system standardized by telecom international bodies. This 5G have its own cybersecurity strategies, norms, and standards, and also the specific communication protocols. From the other side, we have railways, an ecosystem of cybersecurity specific to railways, and also railway operator, they have also their own cybersecurity strategy. So we need a global cybersecurity to be taken in account in the migration strategy, taking in account all the contracts related to 5G, railways, and also local codes related to each country. Another one of the solutions that are revolutionizing the depot, the railway sector and the depot in France and also at an international level is the 5G private network. Depots are considered as a critical environment where complex environment where critical operation are needed, critical communication, seamless data exchange, and also lots of and among coordination between the maintenance agent and also sometimes between the control center depot. Today, we still have some depots still rely, the majority of the depots still rely on traditional railway network, and this is not compatible with the new operational new maintenance operation and the digitalization and preventive maintenance. And this is where 5G came into place. By adopting 5G, the railway operator will gain ultra-fast, low-latency application, including, for example, real-time video inspection that allow experts to diagnose issue remotely, and also continuous monitoring of rolling stock and infrastructure by using IoT sensors, augmented reality tools that guide technicians through complex repairs step by step, and also instant communication and coordination across maintenance teams and control centers. At Egis, we have recently, in the past 2 years, developed and defined and a lot of 5G technologies inside the depot. And the typical architecture of 5G network will require 3 main elements. User equipment are the device, such as smartphone, tablets, IoT sensors, or any industrial machine that can be equipped with SIM card. And we have the second part of the network, which is radio access network, which represents the small cell and also the macro cell that provide wireless connectivity inside the site, and that ensure the connection between the user equipment and the core network. Then we have the third main part, which is the 5G core network. It's the heart of the 5G architecture. It manages data routine, session management, authentication, and also policy enforcement. The core includes a lot of components, including access and mobility management function, session management function, user plan function, authentication server function, and unified data management. For one of the depots we designed recently, we needed, for example, 4 outdoor 5G site, and we needed 21 indoor small cell inside the building of the depot, between 3 or 5 small cell by building. We needed also, as the high requirement, the high availability and reliability requirement of the client, we needed to design a 5G redundant network. And of course, all of this was connected by specific optical fibers cabling and by designing a specific multi-service network. To success all those projects, of course, we need, from the beginning of each of the earliest design stage, to support methodologies, strategies, and some tools to detect all the interfaces problems and to gain in terms of performance. One of them is the beam. I will give the floor to my colleague Doha, that she will explain for us the use of beam in two of the recent railways Egis projects in the last 2 years. Doha, the floor is yours.
Thank you everyone for joining us today. So today I'm pleased to introduce you the Oman Railway Project, which is a cross-border link connecting between Oman, Swar Port in Oman and Abu Dhabi. The project covers approximately 180 kilometers of a new railway aimed at strengthening logistics, trade, and regional integration between the two countries. So on this map, as you can see, the two main sections that concern the project. The UAE section from Al Watba to the Oman border is the red one, and it was led by Jacobs Engineering. And the second one, the Oman section from the border to Swar Port, it's about 80 kilometers in total, where Egis was engaged. So in 2023, Egis delivered key services on this project, including the design review, a value engineering, preliminary design, and tender documents, also as the procurement of the Omani section. So basically, this project was developed by Etaflir in 2040, and it was updated and validated by Egis to meet current technical expectation of the client. So it's a major project for the regional connectivity between the two countries, and now I will guide you through the scope of our achievement and expectation of the project. So this project is led by a joint venture between Etihad Rail and Etihad Rail in the Emirates and the Oman Rail. What's really interesting in this project is that each entity or each country has different objectives. On one hand, there is Etihad Rail, who aim to optimize the basic project with, by focusing on reducing the cost, moving from $3 billion to $2 billion. And there is, on the other hand, there is Oman Rail, who has as an objective to the fast implementation of the project. So a major challenge for us was ensuring the consultation of the design and build companies within a tight time frame, which is 6 months. As I said, one of the major challenges of this project was the extremely tight schedule. So we had only 6 months to move from a design review, then a preliminary engineering phase to the consultation stage, a call for tenders, and the procurement of the project. So in other words, we had to finalize all the studies and optimizations and prepared the necessary tender documents for the client within a very short time frame. So our role as the lead consultant for both Oman Rail and Etihad Rail was to support these two entities which has slightly different objectives. As I said, Etihad Rail was focused on reducing the cost of the project, while Oman Rail aimed to fast implement the project. On this slide, I would like to highlight the key design criteria and the main challenges we have faced on the Oman section. The railway concept design was developed for a design speed of 200 km per hour for passengers and 80 km per hour for freight, where the terrain or other constraint required the speed was locally reduced, for example, to 160 km per hour in constrained area where we had to implement tunnels. The maximum gradient was set to 1.45% to get carefully adapted to the topography, which is slightly higher than the usual. The goal was to reduce the length of the tunnels. The project presented several important challenges. First, the terrain was extremely rough, with a mix of sand dunes and in mountainous area that we had to avoid, which require some complex structure like tunnels and a huge viaduct. In addition, we had to make adjustment to the design speed in certain sections to match the topography. Another issue was the absence of the flat area, which make the location of the passing loops complicated. We also dealt with a very large data and the bulky DTM models, and we had to manage multiple alignment to lead the optimization of the project. Finally, a key part of our task was managing the trade-off between the costs and the deadlines to respond to the client proposals. In response to these challenges, we carried out several optimization studies by analyzing different alignments and alternatives. We explored multiple options, as you can see on the screen. The blue alignment represents the basic alignment made by Itaflir, connecting between the border of the two countries to the Soar port. As you can see, there is the first optimization. We have explored a new corridor that helped reduce the length of the viaducts. In the second one, as shown in the screen, we proposed a new alignment running alongside the highway. We tried to gather the two infrastructure, which allow us to reduce both viaduct lengths and earthworks volume. In the third optimization, we tried to eliminate 1.5 kilometers of tunnels, but this option was eventually abandoned as it doesn't meet the technical requirement of the project. In the optimization number 4, we aimed at removing a huge viaduct at the Wadi cross section. And in the last optimization, we studied a new alignment to avoid the Wadi, so we could avoid implementing a viaduct. As you can see in this table, there is a sum up of the optimization we had proposed to the client, which allowed us to optimize approximately $9-10 million, which align with the client goals. In the preliminary design phase, Egis had to optimize project costs over a very long alignment with a large data and constraint, or under tight deadlines. So we choose Open Rail Designer is a software, conception software to study the project. So thanks to this software, Egis was able to work on a long and continuous alignment without needing to break it into parts, which is usually time-consuming and not effective, either in terms of calculating earthworks or processing the terrain. That's why we decided to go further with this tool, and in coordination with Bentley, which is the software company, we customized and configured the software to generate automatically deliverables that meet the client expectations. As you can see, for example, the figure 1 represents an example of the deliverables that we send to the client. It's a profile view and a plan view of the project. However, this project in this phase mainly focused on CAD deliverables production. We didn't explore a full beam approach. We weren't working in a connected data environment with live collaboration or model-based coordination. Those are one of the examples of the deliverables that we configured with the software in collaboration with Bentley to meet the client's expectations. And however, this project mainly, as I said, mainly focused on CAD deliverable production. We didn't explore a full BIM approach. We weren't working on a connected data. That's what we are now aiming to test and implement in our current project, the California High-Speed Project, where we are starting to use a new platform to support a more integrated, collaborative BIM workflow. As I mentioned before, at Egis, we mainly work on new high-speed railway project during the concept and the preliminary design phase. We have been using a traditional workflow, mostly producing 2D and 3D CAD files and sending them to the client. But now we are focusing on moving beyond that. Our goal is to adopt a true BIM methodology, not just creating models, but integrating online data, visualization, and collaboration into our workflow. So the key enabler of that is this platform. It's the iTwin. So with the iTwin, we are no longer managing static files, but we are managing smart and connected data. So it's cloud online-based platform that is accessible to a wide range of users. No need for heavy software or a powerful computer to check the project. You only sign to this platform, and you can check all the project, all the information related to the project. So this will make the coordination faster and support a better decision-making and increase efficiency at every stage of the project life cycle. As you can see, this is the iTwin connector. In the iTwin connector, we can add all the data related to the project, and it's coming from any software company like Civil 3D or OpenRail Designer. We can add data related to the geospatial data, to the terrain, the earthworks quantity data, and everything. We didn't have the chance to test the iTwin on the Oman project, but we currently actively testing it on the California High-Speed Project. On this slide, you can see the iTwin interface, where you can see the 3D models with the profile view, the cross-section views, and you can see information related to the models. It allows any user involved in the project. You don't have to be an engineer or a technician to check the project. You have an easy access to the key deliverables such as plans, profile, cross-sections, alignment, geometry reports, and quantity reports all directly within this platform. So this approach will reduce the need to produce any traditional deliverables like 2D and 3D plans from AutoCAD, for example, by streamlining the collaboration and improving accessibility across teams. So, for example, in the design stage, the iTwin help us to review 3D models online, so no heavy software needed. We can federate models from different teams, track, viaduct, channels, without the need to federate any XREF or plans. We can run a design validation tools like clash detection. We can, for example, if there is a manager or a project director can provide a design review online on the app. If you design a railway alignment in a software application, you could just upload the project on the iTwin platform and review it with the other team via the iTwin design review on the cloud directly. So at Egis, since our team work on a large number of concept design projects for high-speed railways, we are looking to introduce the iTwin platform to our internal team first and maybe share them with the client later. This will help us to enhance collaboration, streamline our workflow, and move toward a fully digital BIM process. So thank you for your attention, and I'm happy to ask any question, either me or my colleagues Maria and Zineb. Thank you.
Thank you very much for this very interesting presentation. Just very simple question. You speak about communication and so on, but as you know, all the communication will be impacted by a cyber attack. How do you integrate this kind of requirement in your specification?
Thank you so much for this question. As I already said in the presentation, of course, cybersecurity is a critical issue that we need to take in consideration every day, every minute, every second to prevent our network and all our assets from any cyber attacks. And specifically for railway network, we have a mix of different ecosystem. For example, 5G, as I said, we have 5G cybersecurity norms and standards. Other side, we have railways standard cybersecurity. For cybersecurity, for example, for Egis, we take this in consideration from a very early stage of design, and we are also developing solution. Our experts, experts in Australia, they are for the moment developing a global solution, cybersecurity solution that take both ecosystem, OT and IT, because every railway client today, he has the critical OT application, but in the same time, he has its own non-critical application that are open and based on open protocol. And we are now working on the development of this solution, global cybersecurity for railways, for OT and IT systems. And it will be, this expertise, of course, will be shared with the other Egis region. Thank you.
J'ai une petite question. Français ou English? What
As
do you
you want.
prefer?
Fresh.
You speak about the migration between
GSMR and
GSMR to FRMCS.
Yes.
You speak about the migration. How long take the migration?
The migration today, if we speak about SNCF, because we are in France, let's speak French. So let's speak about the French network. Today, the strategy plan for SNCF is 3 years, between 2032 to 2035. 3 years. 3 years, it's very short. And that's why some telecommunication providers are proposing what we call long-time support. And they are saying that they can still provide and support GSMR until 2040. It will depend, the migration will depend on each country and on each strategy plan, but also it's related to the deployment of ERTMS in Europe. There is a plan of ERTMS deployment and need to be compatible with FRMCS. So if we need to have an interoperable system signaling and communication, we need to anticipate the migration to FRMCS, and I think all the railway operators now and infrastructure manager are doing well because we can, for example, find on the European Union site all the migration strategies proposed from GSMR to migration, and we can see that all the migration are proposed from 2032 until, for example, 2035, until, let's see, 2040. In other maybe countries, not Europe, but worldwide, it will take time, of course.
Thank you.
Just one question regarding the last part of the presentation. You talked about BEAM, and I was just wondering if you use BEAM 4D or 5D in the projects that you've done.
For the moment, since we work on a concept design and preliminary design phase project, so we mostly work on a 3D BEAM, like we visualize the 3D models on the iTwin. But in the future, with since now we are still testing the iTwin, but we would like to implement maybe a 4D BEAM where we could visualize the 3D models. We could see all the information related to the project. Either it is, for example, earthwork quantities, data about the alignment, where we could make a designer view. We also would like to have geospatial data connected to the platform. We don't need to implement any 3D models for example, from any application software.
Thank you. Maria, you speak about innovation, but how Egis will support concerning the requirement linked to the eco-conception or this kind of requirement? Thank you.
Thank you very much for this question, because as I said before, it's one of my favorite topics. Eco-design is completely embedded in our design process, from the very earliest stages to the supervision of the works on site. All the innovations that we are pushing helps also the eco-design process and all the items that are at the stake. I have talked about EVA Carbon tool, but I could have talked also about all the tools that help us, for example, to optimize the soil, les mouvements de terre, that have an impact in terms of carbon emission, of course, and that have an impact also from an economical point of view. So eco-design is at the center of our design. All the innovations needs to foster and to push our commitment on sustainability.